Here, we have just a couple of minutes left. I want to show you just this first reaction, and then we'll finish the rest of the reactions next time. Okay? For the rest of this chapter and the other reaction types, it's mostly going to be about identification. There will be a little bit of prediction that we can do, for instance, in this first one. Combustion reaction. Whenever we see fire or flame, that's the result of this particular type of chemical reaction. It's normally a carbon-containing compound. Doesn't have to be, but that's the most common. Okay? All of our fuels that we burn are carbon-containing compounds. They react with oxygen in the air, and if they react fully, they produce carbon dioxide and water. So this is the general format for writing any kind of combustion reaction for a carbon-containing compound. So if I wanted to write combustion of methane, that's CH4, I would do CH4 plus, what's the other reactant then? O2. Let's leave room for coefficients. Okay. And here, I'm going to put phase labels too, because methane is a gas. O2 is it's what you breathe, so that's a gas, okay? All right. CO2, also a gas. H2O, when it's produced in the middle of a combustion reaction, right? H2O is normally a liquid, right? But when it's produced as part of a combustion reaction, what would it be? Yeah. If we produce water right in the middle of a flame there, it's going to be water vapor. It's going to be H2O gas. Okay? So I think all we need is a 2 here to balance that. Then we're good. But we used Bunsen burners like this in the gas lab. This is the chemical reaction that happens in a Bunsen burner. This is natural gas. Right? Methane is in natural gas. The reason we adjust the Bunsen burner is to allow just the right amount of oxygen in, right, to get carbon dioxide and H2O formed as a result. It's called complete combustion when we have plenty of oxygen available to make carbon dioxide and H2O. Yep, thank you. Yeah, because we got 2 O's here, we got 4 O's. So then we're good. Okay. In cases where there is not enough oxygen, like if you were to close the little vent on the Bunsen burner and not allow enough oxygen in, the flame turns yellow and it starts giving off smoke. The smoke is usually carbon. Okay? When we've got plenty of oxygen, we make CO2. When we have very little oxygen, we make carbon. What other gas do you suppose we can make when we don't have quite enough oxygen to make CO2? What's the invisible gas that kills you if your furnace malfunctions? Carbon monoxide. Okay? So that's why it's important to have enough oxygen going in there. If you don't, it's producing carbon monoxide, which is much more poisonous, and regular carbon, which is just smoke, usually. Okay? So we will look at the other reaction types next time. Maybe if I get a chance, I'll show you a couple of them. I don't know. We'll see. So see you guys in the lab.